Since we've understood a little bit about percentiles and quantiles, let's understand a concept called median absolute deviation, which has the same notion as standard deviation, right? I'll explain you. Let me dive into the concept in more detail. So, what is your standard deviation formula? Your standard deviation is nothing but, again, it's always important to read equations in English because that gives us a better understanding. It's basically square root of, right? It's basically square root of the average, right? This whole thing is nothing but average, right? It is the average distance of each of your points from the mean value. So what you're doing here is for each point xi, you're taking how far away it is from mean and you're squaring it because you want to treat points which either lie on one side of median, one side of mean. So let's assume this is my mu. Let's assume this is my x1 and this is my x2, right? I want to subtract. I want to get this squared distance, right? I'm taking these distances, I'm squaring them up, and I'm taking the average distance and I'm square rooting it, and I'm applying square root because I've squared it here, right? What it's telling me is what is the typical deviation of each point from the mean, right? So let's understand, on a similar note, let's understand median absolute deviation. I'll explain what each of these parts mean. So median absolute deviation is, so given a bunch of numbers, let's assume this is the median, given a bunch of observations, let's assume this is your x1, this is your x2, so on and so forth. I'm going to take the distance between these two. The distance between these two is nothing but xi minus median. That will give me the distance between the point xi and the median. And I'm going to, so this is nothing but deviation, right? This part is nothing but deviation. And I'm taking absolute value because since x1 is on one side of median, x2 is on the other side. If I just don't take median, I will get this as positive value, and if I'll get this as a negative value. To avoid that problem, I'm going to take an absolute value. So this is nothing but, when I apply my absolute value function here, this is nothing but absolute deviation. And what I'm going to do on top of this is, I'm going to take the median of the absolute deviations of all the points for I equal to 1 to n. Right? So what am I doing? I'm basically saying, take the median value for each of the points, see how far away it is, and compute absolute value so that both positive values and negative, because what I care about is the distance. How far away is this point from median? I don't care about the sign, right? After taking all of them, I'm saying, compute the median of that. And you might ask, why are we computing median here and why not mean? So I could have also computed mean here, but I know if one point is very far away, my mean can get corrupted very easily. So median absolute deviation intuitively is doing exactly what your standard deviation is doing. It's measuring how far away are my points from the central tendency, which is median in this case, right? So, and it's very easy. So to compute median absolute deviation, it's not readily available in NumPy. So what we do is there is a toolbox called stats models from which we can import robust. So robust has this function called MAD, right? If I just say robust.mad and give a vector of values, it will give me the median absolute deviation. So median, just to summarize it, is the equivalent of mean, except that median doesn't have the problem of extreme points or outliers. And median absolute deviation is one idea which is equivalent to your standard deviation, right? There is one more related idea called IQR. IQR stands for Interquartile range. Okay? We'll see why IQR is useful little later when we start plotting some of this. IQR is nothing but, take the 75th percentile value, right? So let's assume the 75th percentile value for some of this data. So let's take this, right? This is your 0, 25, 50, 75. This is your 75th percentile value for setosa petal lengths. This is your 25th percentile value. If you subtract both of them, what you get is so if you subtract the 75th percentile value, right, and if you subtract the 25th percentile value from that, what you get is the interquartile range. So here the interquartile range here is roughly like what, 0.175, right? So which means in this short interval of 0.175, 50% of your data lies. That's what it means by an interquartile range, right? So it's interquartile because I'm taking the third quartile and the first quartile and I'm saying how many points. So this is where 50% of your points lie, right? Because 25% of points are below the 25th percentile. and 75% of values are below the 75th percentile value. So we'll see how to use interquartile range. Some people also use interquartile range as a proxy or as an approximation for standard deviation, but that may not be the right approximation all the time. MAD is a better metric to use because we just saw it geometrically that it's very similar to your standard deviation, except that your MAD also doesn't have the same problem of outliers. It doesn't get corrupted by outliers. Having said that, now let's go and plot some of these interesting concepts. So we have covered, just to quickly recap, we have covered what a median is, what a percentile is, what a quantile is, what is an IQR, and what is MAD.